Right, welcome back. Math 1910. We are still doing our algebra review, so we're in chapter P. We're doing section 2 right now, and we're going to go over linear models and rates of change. What are we essentially doing? We're finding slope. Alright, slope, very, very important topic in calculus. Everything that you're going to learn in this lecture should be reviewed to you, and it is stuff that you are going to use extensively throughout calculus, so the algebra behind this is very, very, very important. So like I said in the last lecture, we really need to make sure that we solidify our basic algebra skills. Okay, it's skills that you haven't used in a little while, so you might be a little rusty. It should just be review, and we should be able to just refine those and make sure that they're in the forefront of everything we're doing. So we're going to find slope passing through 2 points, find slope through a specific point. All right, use it as a ratio, sketch the graph, understand slope-intercept form, point slope, and then understanding how equations can be perpendicular or parallel to one another based on the slope. Okay, so remember what slope is. Okay, it's a non-vertical line, and it's measured in units. It's rise over run, or change in y over change in x. So that's why we use the term delta y divided by delta x, where delta y is y2 minus y1, and delta x is x2 minus x1. So it's the ratio. It's the change in y, change in x. So you have to remember to keep it that way. And you've learned this, so this should be review, right? So if we are doing everything in forms of delta. So just remember delta, the little triangle symbol there, means change. So that's what we're really doing. So we have delta y, delta x. We're going to use delta y and delta x much more than using rise over run. But it's the same thing that you learned years ago. So this is the slope equation, right? M is the variable that we denote with slope. All right, and we're talking about a non-vertical line. All right, remember, if the line is vertical, okay, the slope is undefined. So that's why this is for a non-vertical line. Other than that, we can define any type of slope, right? Whether it's zero slope, negative slope, or positive slope. So remember, M is slope, right? It's delta y over delta x, or we always deem that as y2 minus y1 divided by x2 minus x1. As long as we are given 2 points. This is going to be really important when we do slope of the secant line in calculus and we do slope of the tangent line. So it's very, very important that we understand and retain how to find slope. Okay, the order doesn't matter. Me personally, I have always just used y2 minus y1, x2 minus x1. You just got to keep track of signs. So whatever one you learned, stick with it. As long as you got the y values on the top and the x values on the bottom, we're good. So just understanding the different pieces of slope, right? And remember, I'm hustling through these. I'm not going to dwell on every slide because this is review. It should all come back to you, kind of as we're talking through these. So, we really deem things as positive slope, zero slope, negative slope, or undefined slope. That's really what we're doing. So if we look at the positive slope, that's the figure on the far left-hand side, where our slope is 1/5. All right, it's positive because we are rising from left to right. As we go from the graph, right, we read it as a book, and we are rising from left to right. So we have an increasing positive slope there, okay? Then if we have the second figure here, notice the y values don't change. Anytime the y values don't change, right, our y value becomes, so y2 minus y1 is actually 0 in the numerator. We have a zero slope or a horizontal line. Okay, and then our third figure, all right, we have a decreasing slope. It's decreasing, right, or the line is decreasing. So our slope is negative. So as we can see, as we go from left to right, the graph is decreasing, so we have a negative slope. And then the last figure on the right-hand side, notice the x values are not changing, so that line there is defined by x equals 3. If the y's, can be whatever you want, but if the x aren't changing, that means we have division by 0, so we have an undefined slope. So a vertical line is undefined slope. So half your homework is going to ask you questions, based on looking at the graph or looking at points and determining, is the slope positive, negative, 0, or undefined? You know, and the best way to look at the undefined one is if the x values are the same on the points. Okay, so any 2 points on a non-vertical line can be used to calculate its slope. And what we're going to do when we get to calculus piece of this is we're going to, you know, use smaller and smaller increments because we want to find the slope of the tangent line. Tangent is to 1 point. We'll get into much more detail on, in later chapters, especially kind of into chapter 1, on what we're really doing there. But we can determine the slope of anything that's linear right now. So algebra is anything that's linear as slope. We need to understand these skills because we're going to find, as we get into the calculus piece later on, we're going to find the slope of curves, okay, of quadratics, of cubics to the fourth, any of those different types of function, exponential functions. We can find the slope, all those different things. Right now we're limited to linear, and this is how we do it linearly: change in y over change in x. Okay, so what we need to understand here is the point slope form. So point slope is going to be important for us all through this first semester of calculus. So will slope intercept form and being able to find the slope and the equations of a line. So you've heard of point intercept before. So what we're doing is we're taking the slope equation of y minus y1 divided by x minus x1, and we're writing it in point slope form. So you guys have seen this before: y minus y1 equals m times x minus x1. That's point slope form, and we use that if we are given a slope and we are given a point. We can find the equation of a line. Okay, so this is by definition, so make sure this is in your notes if you don't remember this. We will use this probably in almost every chapter that we do in calculus in one form or another for the first couple chapters, okay? Because we have to find the slope of the tangent line, and we need a point and we need the slope to be able to do that. So find the equation of the tangent line. So we'll be able to find the slope, and then we want to find the equation of the tangent line in calculus, and this is what we will have to use most of the time. So you have to remember point slope, and you have to remember this equation, and you have to be able to apply this equation. All right, so y minus y1 equals m times x minus x1, where y1 and x1 are a given point on a line, and m is the slope. So let's do an example just to review for you guys. So we want to find the equation of a line that has a slope of 3 and passes through the point 1, negative 2, and then we're going to sketch the line. So we define 1 and negative 2 as our x1 and our y1. All right, and m is 3 in this scenario, so we literally just use point slope. We substitute in our x1, y1, and our m into the equation, and we solve algebraically. Please remember to keep track of signs. So when you substitute in a negative 2, please look at what's going on the left-hand side. We have y minus a negative 2. That becomes y plus 2 on that side. Okay? So just be very, very aware of signs when you substitute in. Okay? And then do the algebra. So on the left-hand side, we have y plus 2. On the right-hand side, we distribute the 3 to everything inside the parentheses. So it'll be 3 times x and 3 times negative 1. So that's why we have 3x minus 3. And then the last step, basic algebra, we should remember we're going to subtract 2 from both sides. So the equation of our line is 3x minus 5, where 3 is our slope and our y-intercept is negative 5. So that is the equation of a line that has a slope of 3 and goes through the point 1, negative 2. This seems basic, but this is going to be fundamental for us finding the equation of a tangent line in calculus. Okay, so very, very important. Or the equation of a secant line, or things like that we might have to find. Okay, so do remember how to do all these steps. And then graphically, we should be able to do that, right? We know the slope is 3, and we know the y-intercept is negative 5. So we know we plot a point at negative 5, right? Because it goes through the y-axis. And then since our slope is 3, it's really 3 over 1. So it means we go up 3 over 1. Up 3 over 1. All right, always doing the vertical piece first on top. All right, and then the x piece will be on the bottom. So then we're able to graph the line. Okay, so ratios and rates of change, it's the same thing for us. A rate of change, distance over time, units of measure, So slope, remember, is always considered the rate of change or the velocity, but it's distance over time for the most aspect, okay? So we can use slope as a ratio here. Okay, so if we have the maximum recommended slope of a wheelchair ramp is 1/12. Okay, and a business installs a wheelchair ramp that rises to a height of 22 inches over a length of 24 feet, as shown in the figure below. Is the ramp steeper than recommended? Well, don't, jump into this real quick and do 22 over 24, because we have to pay attention to units. All right, notice that it's 22 inches high and it's 24 feet long. That is not 24 inches. So we got to be very careful to make sure that we calculate that 24 feet to inches. So that's 288 inches. All right, so 24 times 12 is 288. So the slope of the ramp is the ratio of the height, right, the rise over the run. So now we're going to do 22 over 288 when we do this. So now we can determine, all right, that it's approximately 0.076 when we do this. The slope of the ramp is less than 1/2, which is approximate, okay? So the ramp is not steeper than recommended, all right? So that's important to note, right? This is where like safety comes in and that sort of thing. It shouldn't say 1/2 there, it should say 1/12. That's why the numbers don't look correctly. It should say 1/12 there, because remember that was part of the problem. So 1/12 is the 0.018. 1/2 is obviously 0.5. Yes, it's less than 1/2, but it is less than 1/12. So it's within the recommendation. All right, so it is safe for them to create that ramp. So they do have to follow those kind of guidelines also in real life. So there's a real life application of slope. Okay. All right, so slope is rate of change here. Just another example here. We have the population of Colorado was about 4.3 million in 2000 and about 5 million in 2010. Find the average rate of change of population over this 10-year period. All right, so what do you got to do? The population is your y, okay, and time. If you do slope, note time is always the x value. Time will always be on the x-axis, so time will always be in the denominator. Okay, so we have to, don't use, necessarily years or those sort of things. Take the time period into account when you do that. So in this case, all right, our x1, all right, is 2,000, and our y1 is the 4.3 million, and then y2 is 5 million. I don't want to read the whole thing up, and the x2 is the 2010. Okay, so change in y, change in x. Okay, so if we do that, change in population over years, so when we run through this, we're going to take the 5 million minus the 4 million and divide it by the change in time divided by 10. So on average, okay, the population is what? Growing 72,700 people per year. Okay, so there's just a way we always do that. Population over time. Time will always go in the denominator. Time is always going to be the x value. So whenever you're in question on a problem and it deals with time, know that time's always going to be the denominator. Okay, so that was just the average rate of change or the growth in that model. Okay, so another form for us is understanding slope-intercept form. This is probably the most common one that you used in algebra, where you had y equals mx plus b. We always use the slope-intercept form because it's easy for us to see the slope and it's easy for us to see the y-intercept. All right, most of the time something was given to us in standard form. Remember, standard form is ax plus by equals c, and we were able to solve that for y equals, and when we do that, we always solve it so it's in slope-intercept form. So this is your slope-intercept form, y equals mx plus b. All right, you will be using this to find the equation of the tangent line and things like that as well. Okay, later on in the calculus chapters. And it's just remember, m is still slope and b is the y-intercept. You might have learned this, some of the new math decided they don't like m for slope, so they did ax plus b or bx plus a, whatever you want to do. Just note the variable next to the x is the slope. The next variable that stands alone is the y-intercept. Okay. So we want to sketch a graph of each equation of these. All right. Well, for us to be able to do that, it's just understanding what's m, how's it impacting it, and what's the y-intercept, where do we start? Okay, the first two relatively easy. The third one, right, we need to put it in slope-intercept form so that we can see it, just a little bit better as we go through here. All right, so this is the first one. I'll step back here. We have y equals 2x plus 1. So if we have the equation y equals 2x plus 1, we can see that the slope is 2 and the y-intercept is 1. So we always plot the y-intercept. Okay, the y-intercept is at 1, so that's when x is 0. So we plot that point. And since the slope is 2, that means we go up 2 and over 1 because it's positive. If it was negative, we would go down 2 and over 1. Okay, the negative when we're talking with slope is always associated with the y value. Okay, so when we plot these, it makes it a lot easier if you just always know that it's the y. So in this case, and you always move y first. So in this case, it's up 2 over 1, up 2 over 1. So when we go up 2 over 1 here and we plot this, up 2 brings us to y is 3 and over 1 x is 1. So the 0.13 is what we would be plotting to graph it. Okay, if we look at this next equation here, the line is y equals 2. There's no slope. The slope is 0. Don't think that it's a vertical line. It's a horizontal line because the slope is 0. So that means y will constantly be 2. So no matter where you go on this graph, y will always be 2, and we get a horizontal line. All right, and then the last equation, this is standard form. Okay, we have 3y plus x minus 6 equals 0. We want to solve this for y equals so that we can see the slope and we can see the y-intercept. Okay, it makes it a lot easier for us. So when we solve this, we move the x and the 6 to one side. Then we're going to divide everything by 3. So our final equation here is y equals negative 1/3 x plus 2. So we know the slope is negative 1/3. So that means we go down 1 over 3, down 1 over 3. And where do we start? We start at the y-intercept. The y-intercept is 2. So we start and put a point at 0, 2. All right, and then we go down 1 and over 3 when we graph this. Okay, so when we take a look at the graph, sorry, that was just doing all the steps I talked through. But if we take a look, negative 1/3 x plus 2, we plot the first point at 0, 2. That's the y-intercept. And then we go down 1 over 3. Down 1 over 3. Still change in y over change in x as we go through this. Okay. Like I said, this should all be, review. So remember, general equation, okay, is ax plus by plus c equal to 0. So that's the general equation of a line. Okay. And where we have a and b are both not 0, that's a vertical line. So x equals a stands for a vertical line. Okay, y equals constant value, that would be a horizontal line. So x equals a is a vertical line. Remember, the slope on a vertical line is 0. Or not 0, sorry. The slope on a vertical line is undefined. The slope on a horizontal line is 0. So sorry about that. Alright, so if we take the summary of equations of lines, so we can look at the general form. We know the equation of a vertical line is x equal a horizontal line is y equals b, slope-intercept form is y equals mx plus b, and point-slope form is y minus y1 equals m times x minus x1. All very important stuff that we're going to be using throughout calculus that we need to make sure the fundamentals are for, especially with this one. Okay, so we want to, using the slope, we can understand if we have lines that are parallel, that means their slopes are the same. The slope of line 1 is the same as slope of line 2. Alright, so we're going to do a couple examples where we find the equation of a parallel line and the equation of a perpendicular line. The way we find the equation of a perpendicular line, okay, is inverse reciprocal of the slope. So, or I'm sorry, not inverse, opposite reciprocal. Okay, so if our slope is m1, okay, our slope of our perpendicular line is going to be negative 1 over m2, but m1 and m2 would be the same there. So it would be negative 1 over m1, okay, to find the slope of m2. So let's do an example here. So this is really how we get the equations of parallel and perpendicular lines. Parallel lines, they have the same slope, okay. If they're perpendicular lines, they have the negative reciprocal, or we call it the opposite reciprocal line. Okay, so let's do a couple of examples here. It says, find the general forms of equations of the lines that pass through 2, -1, and are parallel to that specific line and perpendicular to the second line. Okay, so we're given a point, all right, and then we can use point slope, but we have to find the slope of the original line. So we're going to take that equation and put it into y equals form. Notice it's the same equation. We're just going to find the parallel line to it and the perpendicular line to it that passes through the point 2, -1. So we need to solve that equation into slope-intercept form. So we're going to solve it for y equals, which you should know how to do. Okay, so y equals 2x minus 5/3. That's the original line. Now we want to find the parallel line, meaning it has to have the same slope. So the slope has to be 2/3 for the parallel line, and then we're going to force it through the point that we had on the previous page here, okay, to -1. Okay, so when we do that, we have to rewrite it and use point slope. So the point slope is y minus y1 equals m times x minus x1. So when we set that up, we have to use m equals 2/3, okay, when we do this. So this is finding the slope of the parallel line. We're substituting in the 2, -1, because that's the point in question, okay, and then we want to make sure that we have the slope of 2/3, okay. So when we do that and distribute and solve everything algebraically, okay, the equation, of the parallel line, okay, will be given there. Okay, so we would solve, if we put it in point slope form, all right, you would add 7 to both sides, okay, subtract the 2x, divide by the -3, okay. So if we want to find the perpendicular slope, and remember the original slope is 2/3, so we have to take the opposite reciprocal, so that 2/3 becomes -3/2. So that's how we're going to find the perpendicular slope. We're running through the same point, right, to -1. We're still using point slope. So the important part is understanding the only difference we do in solving this using point slope is for a perpendicular line we have to use the negative reciprocal slope, which means we flip it so that 2/3 becomes -3/2 when we solve this, and we can simplify down and get the general form. That's the line that's perpendicular to the original line and goes through the point to -1. The original line is the blue line, 2x minus 3y equals 5. Okay, and then we can see the parallel line there is the 2x minus 3y equals 7. That's the first one we calculated for. And the reason is we're leaving it in that form instead of saying y equals is because the problem asked us to keep it in standard form. If it asked us to use the slope-intercept form, then we would have the y equals form. And then if we look at the other line, 3x plus 2y equals 4, that's the equation of the perpendicular line. It's perpendicular to the blue line, right, and it goes through the point to -1. So just want to clarify on that, why it's in that form instead of y equals form. Alright guys, but like usual, email me if you have any questions. Like I said, this entire chapter should be review, but I really want you to be serious about it when you do this chapter, because you need to have these skills in the forefront as we move into learning the calculus, because the fundamental skills that we have here you're going to need in calculus, and I don't want to have to stop and reteach these, so that's why we're doing them at the beginning. I'm expecting you to know all these like the back of your hand as we move through calculus, because some of the examples I'm going to skip ahead, and assuming that you know how to write the equation and find the equation of the line and that sort of thing. So it'll really help that you understand and are able to fill in the gaps as we move through here. But also let me know if you need to team meet or Zoom meet or anything like that. Else guys, have a great day. I'll see you in class.